Hello, Mr. Hirner. A warm welcome from Team B and myself regarding the submission of Lab 2, the CTEL Tender Stage 2. In this stage, we have embraced the challenge of delivering a fault management system and a workflow management or ticketing system utilizing open source software components licensed under the GNU General Public License version 2, 3, or similar. Following the completion of stage 1, where we focused on the inventory management solution, our team has undertaken the task of selecting suitable software components based on the requirements outlined in the CTEL Tender Stage 2 document. Our objective is clear: to provide a robust, cost-effective solution that aligns with CTEL's needs while adhering to budgetary constraints. In this presentation and already provided submission, we present the high-level architecture of our proof of concept, offering insights into the network diagram and interface descriptions crucial for seamless integration between the fault and workflow management systems. Additionally, we dive into the single sign-on and LDAP integration, essential for enhancing security and user experience. Our presentation is structured to address key functionalities outlined in the CTEL Tender Stage 2 document through detailed use cases. First, the workflow management system, demonstrating the ability to create and assign incident tickets efficiently. Second use case, the fault management system. Here, showcasing functionalities such as event or alarm viewing and triggering events on network elements. And last but not least, the integration of fault and workflow management systems. Here, we are highlighting seamless integration by triggering events, creating incident tickets, and displaying them across both systems. Now, I will hand over to my colleague Esad, who will start with the content presentation of the high-level architecture. Please, Esad, go ahead.
Now I would like to talk about our high-level design of our solution. So we have 4 big systems or components which together make up our proposed umbrella management system. And I will talk about the lower half for now. So each of those 4 systems are separate Ubuntu Linux machines running within the virtual LAN of our proof of concept. On the left-hand side, we have one server which has a Zabbix instance running, which is our fault management system with its own MySQL database deployed. So the Zabbix instance talks to the database for data management, user management, and so on. And the same is true for the Redmine instance. Redmine is our workflow management and ticketing tool. And this also has an internal MySQL database, which is needed for Redmine to run. Both Zabbix and Redmine offer a graphical user interface for users to manage and handle problems or tickets. So these are both accessible through a standard web browser. Zabbix also talks to Redmine through Redmine's REST API. Within our proof of concept, this is mainly used for the creation of tickets. So when you have an alarm or problem in Zabbix, you can automatically within Zabbix create a Redmine ticket. Okay, one more thing we do on the top right hand side, you can see our LDAP server, which is also a separate Ubuntu machine, which has Open LDAP running on it. And this is used for creating, editing, or deleting users and assigning certain roles to them with their credentials and so on. And this is set up so that we have so-called just-in-time user provisioning. So if a LDAP created user logs into Zabbix or Redmine for the first time, their user gets created on the fly, even though before the users were not even present within those systems. So this is the centralized authorization system in our proof of concept. And Zabbix and Redmines are configured in a way that they check credentials not within their respective databases, but they go to Open LDAP to check user credentials. What we also added is this PHP LDAP admin, which is a PHP-based web interface for administrators or operators to manage user data through a web browser as well. And lastly, we have yet again an Ubuntu machine, virtual machine, which is the so-called dummy network element. The main part of that are some shell scripts that send SNMP data, SNMP traps towards the Zabbix monitoring host. And also a Zabbix agent is running on that. This is a client-side service that enables further monitoring, and we use that for scanning and retrieving syslogs from the dummy network element. And this is also triggered by the shell script. So we actually write logs that are being interpreted as a problem or as a resolving of a problem within the Zabbix instance. So we can create fake alarms, fake faulty syslogs, fake faulty SNMP traps, and also resolve them. And we show that in our use case later on. And for further ease of use, and for this proof of concept, we also deployed a web server, which allows us to trigger those scripts through a web browser again. And this all together concludes our high-level design. Now, I would like to talk about our network setup using this network diagram. The most important part of this is the machine on which the actual proof of concept is running on, which has a distinct IP address within a standard local network that has access to the internet. And other machines could theoretically connect to that machine and use the applications within the proof of concept. So this host has VMware installed and runs a number of virtual Ubuntu machines. And each of those have a network adapter or network card that are each connected to their own virtual LAN with the subnet mask 10.00x or 10.000/24. And they by themselves don't have direct access to the internet, but the gateway is an exception, which actually has an additional network card that is shared with the host. So there is this tunnel, I would say, that allows the gateway to actually hook up into this network and have access to the internet. So this is for the gateway. The gateway has its own VLAN IP, but also an external accessible IP address so that machines from the outside and mainly the host can talk to the gateway. So the gateway has two network cards set up. And the other virtual machines use this gateway as the standard gateway. So they actually utilize this virtual machine to gain access on the one side to the internet, but also the gateway has port forwarding and routing configured so that if the host wants to talk to LDAP or the Zabbix instance or Redmine, it can achieve that by talking to the gateway using certain port numbers, and the gateway redirects inbound traffic to the respective virtual machines. And each of those virtual machines as well has fixed VLAN specific IP addresses. So I just want to quickly show. This is actually the gateway when you look at the IP address on the top of the browser. So 192.168.133.128, which corresponds to this IP address. But it has a simple HTML site configured so we can jump to each of the elements within the VLAN. So if you look at this, we can see that we can talk to LDAP, Zabbix, Redmine, and the dummy network element, which by themselves are part of the VLAN. But we achieve this by, and I'm opening the links here. So if we talk to the gateway's external address and put the port 7070, the gateway actually redirects that traffic to LDAP. So the internal IP address 10.0.0.5 is used, but for us, it looks like we're talking to the gateway on the port 7070. And the same we do for Zabbix, which from the outside world is 9090 on the gateway's external port. For Redmine, it's port 8080. And for the dummy element, it's port 6060. And this is achieved, again, using routing tables within the gateway. And this concludes our network overview of our proof of concept. Okay, now I would like to talk about the interface description between our fault management and workflow management system. So Redmine offers an interface that we integrate into Zabbix, mainly for the creation of Redmine tickets within or from within Zabbix. So when we take a quick look at the Redmine documentation, it offers various APIs in either XML or JSON formats. And what we are most interested in is the issues endpoint. And there are many things offered here, but the thing that we used is the post issues, which is used for the creation of an issue. So you have to pass some parameters, such as the project ID. This is the Redmine internal ID of the project that you use. The tracker ID, a status, you can assign a priority, a subject, which ends up being the title of the issue itself, then the description. This is the body, the actual text within the ticket. You can have a parent issue. You can assign the issue directly to a certain user. You can make some estimation. You can put it in private. You can also define some custom fields, and we link this in our document, which are defined in the Redmine's documentation as well. So this is just the basic structure of how we do this, or how the interface is defined. And I have project 2 running and open in the Redmine web interface. And using this HTTP client, this is the bare minimum that you have to send in order to successfully create a Redmine ticket using the API. So this is the actual address for the gateway, and we can send. And now we created a ticket in Redmine. If we refresh our page, we can see that this test issue has been created through the API. Now, one detail that I think needs to be talked about, the way we integrate this is using scripts in the alert tab within Zabbix. And we have the create Redmine ticket script. And this is a very important aspect of this. These are so-called Zabbix macros that allow us to extract certain data of the event or trigger or the host that is affected. So if an alarm or error occurred, we can define some parameters that can be injected into the actual script. And this is the mechanism we use to populate the Redmine ticket with certain alarm data. So the way we do this, we have the Redmine URL. This is actually the VLAN URL, or actually it's an IP address. And we take those parameters by parsing it through the value variable. This is just Zabbix specific. And here we construct the post body, so the issue object that we also saw in this scenario. And here we say we detected a problem from the event name and the host name. In the description, we say a problem has been detected and some details with the problem ID, the network element, which is the host name, the date and time that it occurred. We also construct a URL for the Redmine user to jump back into Zabbix from within Redmine ticket. And here the actual request is being created. We add an API key, which we hard-coded in this case. This is just the technical administrator user. And yeah, we add that header, X Redmine API key. And then we do the post request itself, parse the response, and if everything went okay, we say the Redmine issue has been created. And maybe I can quickly show this. Again, if I open the network dummy element and we say SNMP dummy down, this should trigger an event or alarm. Then we go to the script itself and we just created issue number 31 or 41. And here we can see the way we constructed the description and issue body with the Zabbix macros. That is what allows us to populate the ticket with problem or alarm data. And yeah, that would be the description of the creation of issues from within Zabbix towards Redmine. So the basic interface description and the part that we actually used within our POC. But yet again, Redmine offers many, many more options that you could use to integrate into Zabbix. So as we discussed in our introduction, we would like to go through the use cases as in the POC specification. But first of all, we would like to show and prove that we are implementing single sign-on with LDAP. We have an LDAP server running within our network, and this is the UI for it, PHP LDAP admin. And we can create users. We have POC user 1, and now we're going to create the second user for our use case, which has a unique username. And we give him an email, a given name. We define a password and the surname. And now we create the user. And for roles, we can also add this new user as a Zabbix user. And now when we look at, for example, our Zabbix platform, we can see that this user is not registered yet in the database because we also do just-in-time user provisioning. So every time the new user logs in for the first time, the user gets created on the fly for him. And here we go. He just logged in for the first time. And if we refresh our admin, we can see that the user is actually within the system. And the same is true for Redmine. In this case, he has not logged in yet, but we can log him in and his user will be created as well. So it was POC user 2. He just successfully logged in. And again, if we refresh the admin page, the user has been created for him on the fly through our LDAP running in the background. Now we're going to show the use case number 1. So with our previously created LDAP user is now logging in. And in Redmine, you have projects, and we created one lab2 POC. And here we can go to the issue view and create a new issue, a new incident. We have a small workflow defined. So on creation, we always have status open. We can assign a priority. And we are first of all going to create the issue. Now returning to our overview, we can assign this to a different user, which is going to be POC user 2. Now we log out of our first user and log in with user number 2. Again, going back to our project on the issues overview. User 2 now accepts the new ticket and he can process it by going to the status and saying it's in progress. He submits it. Now it's in the workflow status in progress. And now we can either directly close it through here, or we can go in and add a comment. This is done. And we assign the status closed. And we go submit. And this issue is now closed. And you can't see it in the overall view, but if we filter through the closed ones, we can see all the closed tickets. And now user 2 logs out again. So now we're going to show use case number 2. We have Zabbix, our fault management system. So step 1 is logging in as our first user. And for the event and alarm view, you can either use the dashboard, but currently we don't have problems, or we can directly go to the problems view, but here again, currently no problems are active. We would now like to trigger an event from our virtual machine, which is the dummy. Okay, now this script actually sent an SNMP trap towards our monitoring server where Zabbix is running. And as you can see here in the problem view, we can see that this event has been consumed. And this is the message it sent. The network element is currently down. We can also look at the dashboard, which is also a way to look at the problems. Now we can acknowledge this incident and do some comment on it. Now this incident has been acknowledged. And also now as the last step, we want to clear the event through the dummy. The dummy is also reachable through the web interface for the operator, and all the scripts it has can be triggered from the browser as well. And we are also going to send another SNMP trap, which says that the error is resolved. And if we now refresh the problem view, actually we have to trigger dummy up. Now this problem has been resolved. And going back to the dashboard, we see there are no current problems. And this is the host overview. Just to quickly show, this is where we define the dummy VM as a network element. And under availability, you can see that SNMP and ZBX is configured, which means that we can listen to SNMP data as well as data from the Zabbix agent. I just triggered 2 problems, the dummy log trigger and SNMP dummy trigger. And I just want to show that under items, under items for log monitoring and SNMP, we can actually see this is a syslog entry from the Linux machine. And this is being retrieved periodically. And we configured this to do every 30 seconds. And if dummy error is within this error message or log entry, then we raise an alarm and we resolve it if it says dummy resolved. And for the SNMP traps, we can see these are all the SNMP traps kept in the history. And we define a trap that says dummy down or dummy up. Dummy down means we raise an alarm, and dummy up means we resolve the alarm again. Lastly, we're going to show use case number 3. We are going to log in to a different user. You'll see user 2, let's say. And again, we trigger an event or alarm from the network dummy. We have 2 ways to do this. We're going to run the SNMP trap as well as the syslog. Going back to the problems. The SNMP trap dummy trigger was already recognized because it immediately recognized it, but the dummy logs actually have to be fetched. This is configured to do every 30 seconds. And now we can display them. We can see them through the problems view as well as the dashboard. Now we can look at the details. We can see what triggered it, which host is affected, in this case our dummy. And use case number 3, the idea is that we have to create a Redmine ticket directly out of our Zabbix fault management system. And for this, you go to the scripts and you click create Redmine ticket. And now a ticket has been created for the SNMP event. And we can also create one for the dummy log. Now logging into Redmine with the same user or a different one, let's say user 1. Going into our project and the issues. And now we can see that the 2 tickets have been created for us. Just to show that it was actually created, I'm going to run another one for the log trigger. And now you can actually see that it has been created on the fly. And the user in Redmine can now again go and put this into progress, which makes it in progress. It has been enriched with some details about the problem. It has an ID, the name of the trigger that created the problem, a timestamp, the network element, and the severity from Zabbix itself, which was high. If we look here, the severity is red, which means it's of high severity. And you can also jump back directly into Zabbix from within the ticket via a link. And the last step would be to process the ticket. So we're going to go closed and close the ticket. And now we can theoretically also resolve the error by running the according scripts. Now the SNMP problem already disappeared because it works in real time, but the log actually needs to fetch. This is going to take a couple of seconds. And then this event should be resolved as well. I'm refreshing here. And already it fetched the log and figured out that the dummy is in a green state again.